Let's talk about hydration. Because plaster of Paris is non-hydraulic binder, or we can say that it's air setting binder, on adding water to the powder, it can easily be shaped and molded, and in a short time it sets and becomes similar to what it was in its natural state. Hydration process is exothermic. When water is added, the gypsum forms interlocking crystals. The setting and strengthening of gypsum are due to intergrowth of these very fine and poorly soluble crystals. Setting of plaster of Paris starts about 10 minutes after mixing and is complete in about 45 minutes, but not fully hardened for 72 hours. Plaster of Paris first shrinks and then expands and does not crack due to shrinkage. Time of setting can be delayed by adding fraction of retardant like glue, sugar, alcohol to accelerate the setting. Less water and salt and cohesiveness, kettle hair or wood fiber can be used. When anhydrite is mixed with water, its setting starts not earlier than 30 minutes and ends not later than in 24 hours. Calcium oxide in the estrich gypsum acts as a catalyzer which promotes the hardening of the high-burnt gypsum. High-burning gypsums show slow setting but ultimately become very hard. When the setting starts, the half-liquid state of the gypsum paste starts to turn into solid. The shaping process should end before this moment. For the hydration, water, at least 20% of the weight of the gypsum powder is required. For better plasticity, it should be 60%, and for viscosity, it should be 100%. Properties of gypsum products. Due to open pore micropores, gypsum is capable of storing humidity in the air by capillarity, and if the air is too dry, the stored humidity in the pores is pushed back in the surface and released to the air around the gypsum product. So we can say that gypsum equilibrates humidity in the environment. But it's vulnerable to water, not suitable for external or internal applications where dampness occurs. When it's exposed to water for a period, it can get damaged. It may lose its structural integrity and become soft, weak, and disintegrate eventually. The still air in the pores causes a low thermal transmittance in the gypsum products. Gypsum is non-combustible and not flammable. Through the action of fire, the crystal water in the structure of gypsum evaporates and a protective layer of powdered gypsum is formed on the fire-exposed surface. Behind this layer, the material under fire attack remains at a constant temperature. The open pores on the surface of the gypsum products can absorb some portion of the sound waves. If needed, these pores can be magnified by the help of admistures and forming the paste. Calcium sulfate is acidic, and if a gypsum product is in contact with iron or zinc, the acidic environment and the humidity held by the pores can cause these metals to be oxidized. In order to prevent rust, two products must be isolated. This oxidation does not happen with copper and aluminum. The mechanical strength of gypsum products depend on the composition and the properties of the product, the amount of water used for hydration, setting retardants or accelerators, the high and continuous humidity level around the product causes a decrease in the compression, and tensile strength. Anhydrite and estrich gypsum are much more stronger than plaster of Paris in terms of compression.